Get started.
Welcome to the October 10th, 2023 session of TangerineSDR and Hamside technical session. Just a few days before the October eclipse next Saturday. And so we're down to the wire here for the first one, particularly for the West Coast people and Southwest. Anyway, my name is Dave, KV0S, and this week I've been working on getting GPS disciplined radios going. I got my RX888 working with an Leo Bodner, and I also got a Leo Bodner into my Hermes. So have been learning how all that works. Not fooled with it. Seems to improve my decoding sessions in K9Q radio. So that's it for me. Next on the list is Nathaniel, W2NAF. Go ahead.
Thanks, Dave. Pretty much standard stuff going on, continuing to write reports and papers. Trying to get, I have my 2 grapes are running. They're all set for the eclipse. As I was saying, I'm having some antenna trouble with 2 of these antennas, so I've got to puzzle that out. Just keep moving. I think the most exciting thing this week was being featured on BBC Future, which was really, really fun. And in case anyone didn't see that, I can put that chat in the link, but I imagine most people probably saw it. So, but it was very exciting nonetheless. W2NAF back to net.
Very good. Next on the list is David, KD0EAG. Go ahead, David.
Oh, hi. I have been engaging in various lessons in humility, working with the KiCad and sending things off to JCL PCB, and getting some of them back, and it's amazing what you can do wrong. But I'm sticking with it and going, moving ahead, and I've sent off some more. So both of the Cypress-based design and of the magnetometer boards too. The older magnetometer boards I've kind of freshened up. So there we go. That's it for me.
Very good. And I hear from good sources that it sometimes takes a few revs to get those right.
Oh, I expected that, but it may be a few more than I hoped.
And next on the list is Michael, AC0G. Go ahead, Michael.
Hello, everybody. Excuse me. I've been working on getting the ability to record some bandwidth around WWV going on a Anon 10 that I have. I've also got an open HPSDR and a Hermes, but figured I'd just focus on the Anon 10, and now I'm trying to, in brief amount of time we have before the eclipse, just try to verify that what I'm storing is good and quality data. The radio is disciplined with a Leo Bodnar. So I'm fiddling with GNU radio, see if it can help. I've been banging around with some Python scripts to see if I can get those to establish that I'm recording what I'm recording. And in any event, I'll have the data and I can play with it after the fact as well. And that's it. Back to net.
Very good. And next on the list is Michael, AA8K. Go ahead, Michael.
Oh, thanks. Thanks very much. My wife continues to need my caregiving, so I'm kind of stuck. Greetings to everyone listening. Back to you, Dave.
Well, hang in there and good luck with that.
Thank you.
Next on the list is Bob N5BRG. Go ahead, Bob.
Hello, everybody. I'm busily working with the grape stuff here too. I've got 2 units working and data coming in, recording it. I'm using GNU Radio to record it. I'm not using the software from Bill yet. But anyway, I am in a position to record both of the units. I built up 3 of them, and I've compared the 3 units, and I'm finding a pretty big difference in sensitivity of the 3 units. So I'm going to be investigating that a little bit more tomorrow and try to understand that and narrow it down to the 2 that I actually want to use during the eclipse this Saturday to record data. But anyway, staying busy.
How are you recording the data?
Well, I'm recording it as a data file in GNU Radio, just feeding the data right into a data file.
Just are you using digital RF, or are you just storing a WAV file, or what?
I'm using a digital RF file.
Okay. Yeah, that's what I'm using too.
I think that's what Mike's doing in the same software.
Anyway, back to you, Dave.
Okay. Next on the list is David N1HAC. Go ahead, David.
Good evening, everyone on the net. Trying to scramble to get some of our AM Doppler units online. They've been taken off, and now they're being very balky about being online, but we'll see if we can get some of them going by Saturday. Have been in contact with Nick Hull Patch and maybe the medium wave group will get some useful data as well. One odd thing, propagation right now is very interesting. Been listening to 10-meter beacons from the West Coast and Hawaii right now, and 25 megahertz WWV is coming in S9 plus 10. So don't know what's energizing our ionosphere, but it's very happy right now. Back to net.
Very good. Next on the list is Franco K4VZ. Sorry.
Hey, good evening, Dave. I'm starting to look into a GNU Radio module to do the so-called filter bank using Field's algorithm. So my idea will be to develop something that is similar to KNQ Radio, but usable as in GNU Radio, so people can experiment with that. I just started to put down the little code and started from the beginning, so it'll take a while, but that's my project for now.
Very
Back
good.
tonight.
It's a cool algorithm, isn't it?
Go ahead.
What do you say?
It's a cool algorithm, isn't it?
The filter overlap and save filter
Yeah.
bank. Yes. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just sitting here making some last-minute preparations for the Solar Eclipse QSO party. Bruce Horn, WA7BNM, is creating a log uploader for us. He's got the page developed, and I'm waiting for him to give me the word to do some testing on it. Other than that, keeping the HAMSI Grape 1 DRF documentation up to date. And that's about it. Back to net.
Very good. Busy week for you. Next on the list, we have Human, KD2 MCR. Go ahead, Human.
Hey, good evening, everyone. Yes, I've been pretty busy with like many other things, standard business. So I'm here to talk about the magnetometer paper that I'm working on right now. So hopefully I can get some feedback about that. So
okay.
Yep.
And let's see. Next on the list would be Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have too much to report, as most of my time has been taken up by non-VLF related projects. but I'm eager to see if there will be any effects from the eclipse on any of the VLF transmitters. The data is currently being streamed over the network from my VLF system to the VLF server. That's where all VLF transmitters are actually monitored. So I could go in and I'll be checking each one. So I'm thinking that if there's any sort of effect, it would be from VLF transmitters that are to the west, possibly NLK and the one in Hawaii, and others. Hopefully the reception is good enough and we will see some sort of effect. The effect that we should see is a small peak, a gradual increase in signal and decrease in the peak marks totality, and there'll be 30%. It'll be 30% here in Pennsylvania, or at least that's prediction. So I'll also be watching with my glasses. That's all I have. Back to the net.
Very good. Next on the list, we talked to Michael. So Tom, N5EG. Go ahead, Tom. Oh, Phil.
All right, there we go.
There you go.
Okay, got it unmuted. Yeah, the mouse is sticky sometimes, or the operator's sticky, one of the two. Busy this week and not going to be able to make the call next week. Going to be out. So put up a video on getting started with KA9Q. A lot of folks watched it. It seemed to clarify things for some people and confuse other folks. So it's a little bit hard to tell. Back to the group.
Well, thanks for trying that, Tom. I think it's a great effort. And going back through some of your old videos at DCCs have been instructive.
Okay.
For me. And let's see. I still haven't called on Phil Karn, K9Q. Go ahead, Phil.
Okay, I'm here. I haven't gotten a lot done the last few days, a few distractions, but I'm about to get started again, making actually lots of little tweaks and enhancements that people are asking for. Probably about ready to start writing some manual pages, which are long overdue for this thing. And also rewrite some of the tutorials, which are a little out of date on how to configure this stuff. Anyway, that's about it from here. Go ahead.
Okay. I think I've called on everybody on the list tonight, so we're open for general discussion.
We could start with Yeoman.
Sure. So let me share my document. Can I have, oh, share screen. Okay, it's here. So overall, the write-ups are pretty much done. Of course, by the way, this is about magnetometer project that will be submitted to HardwareX paper. The author list is not complete at all. I'm planning to add other people. Recently, I have added John Gibson's, so it's already here. So if you want to contribute to this paper and want to be part of this co-author, please let me know. This is never be a complete list, so I'll be happy to take any other co-authorship if you're willing to. So the paper, the the structure is pretty much similar to any other science paper. The major difference is the fact that they want us to add all these like details about the project materials and design files, and we have to declare that this is open source. So there's some technical stuff that I'm not really familiar with, and but thanks to many other people, including Dave Witten. Unfortunately, Jewel Maddie passed away, but he left a lot of useful information. So I'm compiling all this, integrating all this information into one paper. But basically, wherever there is the highlighted, those are the one that needs to be completed. So the paper talks about introduction, why we need magnetometer, what's so important, how that looks, what kind of magnetometer we use. So followed by the second section, hardware description, to talk about the more details about the technicalities, technical side of the magnetometer. And of course, it shows all the figures that depicts all the system design, even the PVC pipe that houses sensor on the ground. So yeah, under the system description, I put most of the information about the magnetometer, but here what they really ask us to share is actually design files. So, and then bill of materials. So those are the things that is kind of unique to this paper. Somehow, anyone reads this paper could maybe reproduce this thing. I think that's the philosophy of this paper. So, and then, but the rest of the part is almost done. I mean, here I talk about, how to operate this, what's needed to operate this software. I can also refer to the documentations that Dave Witten put in the data portal, how to install this, how to align the sensor, the picture of the installation, and how do we validate by. So basically, we compare the data with the scientific magnetometers nearby. So here's the thing: what is closely located magnetometer that you can compare? It's all relative, but if you have, say, magnetometer within, I think there's a paper that talks about that, about plus minus 100 kilometers from the magnetometer, you actually integrate signal from the ionosphere. So, if the other magnetometer is within, say, 200-ish kilometers, then usually you will see very similar signals. So, do you really want to have like kilometer separation or tens of kilometer separation? I guess it's very relative, but however, we have science grade magnetometers, especially in Fredericksburg, Virginia, and Boulder, Colorado. So we were able to compare magnetic field signals with those scientific magnetometers that are being run by the United States Geological Survey, which is one of the government agencies. So we were able to show that, I think there should be, this one shows the magnetometer data from Iqaluit, which is science grade magnetometer, Ottawa science grade magnetometer, Fredericksburg, Virginia science grade magnetometer, Boulder, Colorado, as well as our the ham-side magnetometers. So this definitely shows that the usefulness of our amateur grade magnetometer, especially if you want to look at large scale current system that we are interested in. So as you can see, the magnetometer data that we have shows very good correspondence with the other science grade magnetometers. The only thing that our magnetometer cannot maybe see would be really small fine scale wave activity, which is of our other interest, like the people who are interested in like some, macro, micro, mesoscale space plasma phenomenon. But that's not the target of our project. We are aiming for looking at this like large scale fluctuation of a magnetic field that is associated with solar activity, geomagnetic storm, substorm that can also be monitored by the HF receiver that you guys are working on. So this paper actually shows good storyline all the way from design, manufacturing, amateur, radio engineer, citizen science involvement, all the way down to validation. So it's in a shape. The place where the area where I need help would be the design file that needs to be shared. So I have received many files from Dave Witten. So I'll be working with Dave Witten. I mean, we have already started working on this so that, which one should be included or not. So that's where I'm right now. And we go from there. I believe there are two different versions, and then we've been talking about this, which one should be included in this paper. But I believe, we've been using Dave Witten's original, the first version of magnetometer, and the data produces a lot of valuable data sets. So I don't see why we should not use the first design. I don't know if the first design is going to be the mass production version, but as long as someone can reproduce the design and show the same level of performance, I don't think the details, the differences in details would be a big problem. So I wanted to ask you what your thoughts are, design file wise.
Well, I've been cleaning up. It's not perhaps exactly correct to say that they're the original version, but they are essentially equivalent. The same thing. I've just been cleaning up the design files and making them in a nice format that someone would be able to work with. And I believe I could provide you those in the next day or two. I have sent one batch off for a new spin of the board, of the local end board. Mine, unlike Scotty's, mine have actually there's two slightly different boards, one for local and one for remote. The way we're using them, there's no great financial advantage to doing them as a single version. And but I've certainly got the bombs, and I've got the everything I think you would want to include. I don't know whether you want to update that photograph or not. Those are actually an early version of the Tapper ones, and they're not functionally different than any of the others, but they don't look exactly like what someone would get from the stuff that I plan to archive. But I don't know how important that is. I think they're not.
I think if we're going to provide the design files, if we could get a photograph of the actual boards, I think that would be preferable.
Sure. I mean, I used to have older version of photos here, and then I replaced it with what was provided by Jules, which I believe the second version, but I can go back to the first version, which shows the Dave Bitten's date version. So yeah, that can be done.
Probably smart to have them correspond the photos and the schematics.
Dave, were you going to order some new boards based on your schematics, your new design files?
I have already ordered the local end boards, and I almost finished the remote ones today, but I might stay up late and send them off, but that doesn't mean there won't be any mistakes. And besides, I have not been able to get them, I didn't have the capacitors. I didn't seem to have the capacitors I wanted. So they're being fabbed without those. But essentially, yeah, the answer is yes. These will be but whether I can make you a pretty picture or not.
Well, maybe I can help Dave with the photography.
Well, it's not the photography, it's the completeness of the boards. But I really think these illustrate, anything we do is going to go through versions, and any paper like this is going to, the things we will provide links to will be good, good versions that someone can use that are functionally identical and very, very similar in form. They won't be orange. They'll be green. It costs extra to get other colors, and I didn't feel like paying for it. But I can provide almost all the documentation, or essentially all the documentation. The only question's about the picture, but I can provide the documentation, all the other documentation, including 3D mock-ups of part, well, not with the magnetometer on, but partial 3D mock-ups in the next couple of days. So that look kind of cool.
Yeah, that sounds great. That includes the PCB design.
Yes.
Right, PCB.
And the BOM, and all the design files. Gerber's, whatever. Yeah.
Yeah, Gerber file. I don't know if that's what the level of the open source file policy is, but
well, I'm using the most open source of all the CAD tools that are available, and the KiCad or KiCad, and I really think it's what anybody ought to be able to deal with it. Any board house these days can deal with it. It should be uploadable and or editable. I think it meets the spirit of this publication really well.
Okay.
That sounds great.
Okay, so I'll be looking forward to receiving the rest of the documents that
Okay,
can go with this. Yep. But I think that's pretty much a bit. I think they call design files and
Yeah.
BOM, bill of materials. So
yeah. Well, what I'm really gonna have, it'll be in several forms. You know, when you send it into the board house, they all want a little slightly different things. JLC PCB likes them zipped together in a single thing. Most of the Gerbers and stuff, and but other ones want something different. What I've got is a complete design folder, project folder that I will ultimately push to my GitHub if I haven't been locked out of it. I think I got it right. And so just like the software link that you have there, there'll also, but I'll send the whole deal to you zipped up also. And but there'll be a link certainly into my GitHub, and it can be mirrored anywhere else we want it to be. The one I can vouch for the most is the one I control. So, because I don't think I have upload capacity anywhere else. So I'll send it to you right away.
okay, that's great. All right,
You
so
mean
go ahead.
Oh, I just want to tell you that I saw in Figure 6 that Scranton is misspelled. Just
Yes.
if you notice that in the legend,
Yeah.
What?
Scranton
on the
is
plots.
Stanton there. So
Oh, yeah.
Oh,
SCTA.
okay.
Yes.
Thank you, Franco.
Wow.
I would not have lived that down.
No.
I used to write papers too, so when I was young.
Very good eyes. Thank you.
Yeah.
Yep. Okay. That's all I have for now. You know, but again, I'll be more than happy to, take more authorship if you are interested in contributing to this paper. Yeah, please let me know. So in my opinion, magnetometers have been around for decades. So it's not, the paper should not only about like just to show performance of the magnetometer, because that's sort of been shown in many different papers. So I think what's more important is the fact that this is like open source design led by amateur scientists, so that it can be built very easily for low cost at home without any special, fancy tools, whatever, so that it can contribute to the scientific activity. So that is the more important thing, rather than just talking about the technology of the magnetometer, because it's been around for a while. However, this very magnetometer type is a little bit different, but that's my feeling. I think this paper should be more about the citizen science involved project, so that
Yeoman, can you send me the current state of that document? Just email it to me.
Oh, okay. I will. I thought I did before, but I'll.
You probably have, but I assume you've made some changes, and I've got lots of versions of it, but
Yeah.
I want to fill in the blanks where I can.
Sure.
Yeah.
After I fix Scranton.
Yes, definitely.
Yes.
Okay, that's it. Back to the net, I think.
Okay. I see we have Rob Robinette on. You missed the roll call, but will you say hi?
Hi, gentlemen. I'm sorry. I was in another eclipse preparation call.
Okay.
The yeah, I don't know what I think the most relevant. This is talking about the 888. I am preparing to go to the eclipse with a. Well, I'm trying to get 888s deployed at KFS, KPH, and take one with me to Winnemucca. And as in all engineering projects, unexpected problems occurred. One of the things I've learned, and I may have told you, I don't know how many of you are actually trying to work with a 888, especially with an external oscillator. I've used both the Bogner, and now I'm using Glenn N6G nth design, which John Ackerman is rebuilding. I'm using that with a 888. So this would be a prototype of what I think of what we would be getting from our own Clementine SDR,
Yes.
which would be John's GPS, Glenn, and now John's GPS DO. Paired with a 888, and that seems to be working perfectly. I have a test setup that I've set up behind me, and this test setup consists of a beacon blaster. Let's see if I can show you guys this. Let's see, this is the transmitter. This is it outputs 6 channels, 6 bands simultaneously, 80 meters through 10 meters. And the little box on the top is a combiner that takes those outputs and puts them together into one output. And that goes to that little antenna. I have a dummy load on the antenna, so it's mostly a dummy load. So this generates GPS stabilized whisper signals on all of the bands. And then I have both a Kiwi and this is a 888 here as a receiver. And both of these are GPS disciplined. This is I hope you can see this now. This is the prototype of what John is building, the GPS DO. So this outputs both 27 megahertz that goes to the 888 and the 66 megahertz, which the Kiwi wants. So this system I've tested as of today, and it transmits accurately and stably within 5 millihertz of programs up through 10 meters. So I think we have design that allows for accuracy and stability of carriers and signals up through 10 meters that in all effect equivalent to what you get from WWV. So so that's one of the things I've learned. If you're using a 888, the external input needs to be terminated. I have a 50 ohm terminator right there on the back panel. So if you don't do that, the cabling, perhaps if it were really short, it wouldn't make a difference. But even with I think I have like 1 foot of cable, there's enough ringing that the clock rings, and then the 888 samples at some undetermined higher frequencies, variable. So with the terminator in place, it is rock solid stable. The 888 sample times are completely reproducible for hours on end. So that's it was really only until it wasn't until this morning that actually got all of this working, and I now have confidence in my transmitter and in my receiver systems. And similar systems are being installed. I have a 888 and a similar pair of systems that are going into service down in Santa Fe. The transmitter's down there, so there'll be a beacon blaster and a GPS stabilized RX 888 reporting spots from Santa Fe, which is near, not right on, but very near the path of the Saturday eclipse. So that one's in place and will be in operation probably starting Thursday. So
Rob, did you get my Bodnar?
yes, I did. I'm sorry. I've been so busy. Your Bogner is sitting there, and it's and one of the things I did was I validated. I used it to verify that Glenn's design is generating almost equivalent stability up through 10 meters. So but it's I need it. I need what you sent me. Thank you so much, Phil, for lending me that, and I'll send it back to you after the eclipse when I don't need so many Bogners. I found I own 8 Bogners of my own right now, and a warning for Bogner users: in trying to set up my my transmit my beacon blaster, I was going to feed it with this little and by in cabling it up, I applied 12 volts to the mini USB port, and it is now completely fried. That was I didn't tell you, Phil. That was why I needed yours.
Well, you did tell me.
I did tell you. Okay. Well, anyway, so it's just beautiful that if you look at the spot reports, the 888 and the Kiwis report exactly the same frequency and exactly the same spectral spreading, i.e. 5 millihertz is the resolution of the JT9 decoder.
Excellent.
So it's just perfect. I also have implemented in the Whisper Demon IQ recording now, so you can record all of we can record all of the IQ files for all of the time stations, all of the Whisper bands, at the same time as we're decoding all the Whisper bands. So that's installed and configured and running out at KFS already. So there'll be those narrowband IQ recordings. Also, thank you, Franco. Your split program was exactly what I needed. And I've just been, in fact, I was working with Brett, who is going to be with Clint, and they're going to be out in southern Utah for the eclipse. And they're taking a RX888, which they're going to record the whole 0 to 30 megahertz spectrum, and that will be using your split program, Franco, as part of the So they have a disk subsystem that can write the 130 megabyte per second that comes out of this split program. So so we are. We're zeroing in on being ready for the eclipse, and we've learned a few things. Now, that's all the plus side. There is one negative side that about the 888 that occurred. I was out repairing things out at KPH on Saturday, and it turned into a 12-hour, 300 miles of driving marathon. But part of the things that I've observed out there is that when the 888 is connected into the system, I saw bursts of RFI from 0 to 30 megahertz occurring, and it appeared to be introduced by connecting the powered on 888 into the network alongside on one of the splits off of a passive splitter. That was pretty upsetting. I then reproduced the same observations also in Santa Fe on Sunday, and narrowed it down by putting in a common mode, an isolation transformer, flux coupled isolation transformer on the path to the 888. This burst disappeared. Well, we didn't know. They were reduced, dramatically reduced, but not entirely disappeared. But but now this morning or this afternoon, I looked at KPH and they're not occurring. But I'm not sure that the 888 is powered on and running there. And we had some problems in Santa Fe, so I don't have the 888 running with the Kiwi in Santa Fe. But I should, anybody who has one, because we don't have a software that looks at a whole 0 to 30 megahertz spectrum, you couldn't see this problem. So you only could see it if you had a Kiwi sitting in parallel to a 888. So it reinforced my concern that we do, without a full-on spectrum analyzer program for the 888, like the Kiwi has, where you can look at the whole spectrum, we're not going to see, we may miss problems in the 888 design. Now, it could be just a configuration problem. I haven't fully debugged this. So, this is preliminary information. But not only is it a concern about the current 888, whether it may be a source of RFI, serious RFI, but also another reason why we need to have our own chameleon or Clementine, where we can control what's going on. Because if this proves to really be a problem with the RX 888, then there's probably no hope to fix it. I mean, I applied some pretty intense isolation to the 888's input, and I could reduce it, but hardly eliminate this source. Again, there's not enough information. I had a 12-hour day. The last thing I looked at, I saw this RFI. I had, it's just not. It would be great if to have some other users in it with a similar configuration, or to have to have a spectrum display from the 888 that gives us the same kind of insights we get from the Kiwi's user interface.
I don't understand this problem. What are you seeing? What kind of noise is this?
I see a burst of noise that extends from 0 to 30 megahertz. You see, it looks like thunderstorms. But
how often does this happen? And when does it happen?
Irregularly, but every 5 to 20 seconds. And it was not regular. I actually had my friend Dan in Santa Fe took the 888 and plugged it into a USB power supply, so it wasn't connected to a computer. It was just powered up, and the problems were still there.
Do you think the 888 is generating this?
The evidence that as far as I got, it's on Sunday with this test. It suggested it was being generated by the 888 on its own. Nothing outside of the 888 was generating this.
No, that's bad news.
It's really, it was, I a little hesitate to tell you guys about it because I'm not sure that, I can't, I didn't, I was trying to reproduce the problem here by connecting the input of my 888 to the input of my Kiwi. But I don't have an antenna on it.
I have the two of them in parallel. I've never seen this.
Well, I hope that I hope that it was something unique to. I wasn't going to be. I was going to think it was something unique to KPH, but then when I saw the same thing happening at down in Santa Fe in a completely different installation, and the diagnostic steps I was able to go through in Santa Fe. It was suggested it was being generated by the 888. Now, it may be something that is transient, that because it seems to have disappeared at KPH. I'd have to go look at it. I haven't looked at it for a few hours, so I don't know what the spectrum looks like. KPH spectrum radios. If you want to see a beautiful receive site, go to KPH right now. It's fantastic. It's just gorgeous. It sounds like
aren't the inputs from the distribution amplifier isolated from each other?
No, it's a passive device. So it's a passive distribution.
Okay, so they have pads or something. They have some isolation, not much.
It's a mini circuit 8-way splitter there, and it's a mini circuit 2-way splitter in Santa Fe.
So the noise being generated by the 888 is getting into the other receivers.
That's what it appears to be, but it appears to be that I put in, as I say, on the path from the splitter to the RF input of the 888, I put in a flux isolation transformer, which has like 60 dB of common mode suppression around 1 megahertz, and I was still seeing it. I was still seeing some of it. It was reduced significantly, but it was the burst of noise. So I have some screen captures which I unfortunately deleted, so I can't. If you give me a few minutes and somebody else talks, and I can share them with you. You can see what they look like. But Phil, I guess you have the same kind of. What do you have an active distribution app?
No, I just have a Y connector. So I'm losing 3 dB, joining the inputs of the two.
Yeah. Well,
to the output of my Paul WB6CXC filter.
Yeah.
But I've never seen anything like this.
Well, it's I'm glad to hear that you're not seeing this problem, and that's reassuring. That's encouraging, and the fact that it's gone away at KPH is somewhat encouraging, although intermittents are almost worse than. But if you didn't actually look for it, you might miss it. Okay, the way it occurs, these are so
broadband.
brief.
It covers the entire.
It covers the whole. Well, some of them extend. They extend up. They depend. Some of them that appear to be longer. They're so brief. They might be 20 milliseconds in length. I mean, they're so brief that what you hear is, if you're listening to something like WWV, you hear a little spurt of noise. But it's just a little spurt of noise that could be. It's almost shorter than thunderstorm noise. It's so it happens so quickly.
Rob, did you have the Bodners hooked up to these when you saw the noise?
I tried it with and without the Bogner.
And same both.
It was present with and without a external GPS.
Okay, the only time I've ever seen that on a receiver is when the oscillator was cycle slipping, and you would get a huge phase transient, and it would show up as just kind of a click through the passband.
I wonder if another possibility would be that maybe I forgot to put the attenuator on the GPS, but no, that wouldn't make any difference. On Ternal, I was also tried it within. I'm not sure now, Tom. Now that you point that out, that it's possible that that I was testing that when I saw this, it was only with the Bogner in. Although it couldn't have been with the Bogner in at KPH because I had no GPS antenna. That was one of the failures out there. Is the rooftop GPS antenna feed went down, so I had no GPS for a week. But so I'm not.
One question about GPS. There was some discussion about modifications of the firmware on the 888 to take 10 megahertz instead of 27. Who was working on it? Was that you, Franco? Is Franco there? Was somebody working on that?
It was Franco, I think, made the change and checked it in. Yeah.
Yeah, that would be very useful. So I can just use 10 megahertz.
Well, he checked it in. I think if you go to his repo, you should be able to get it.
I will do that.
Yeah, it'd be great to have. It'd be great not to have these different. Well, the Kiwi I can't change, but
well, especially since you now have my Bodnar, I can't.
Yes, I know. Let's see. Okay, let me see if I can show. I'm looking back through my trash to look for the files and look for the. There's an example. Let me see if there's a better. Going farther back. Yeah, here's an example. Let me bring this out of how do I get this? I put this on my desktop and then I open it with this program and I can show it to you. And let's see. Share screen. There it is. Okay, you see those bursts that you see and notice that they extend through the through the AM band where there's a 80 dB blocking filter.
Yeah,
So
well,
they're not a differential signal coming from the antenna.
right.
There's something.
Could those not be actual noise, but sampling problems?
I mean, Tom's sampling problem might explain this. Yeah,
Yeah, if there's a slip in phase, it would certainly do this, wouldn't it?
well, I had no. I didn't know that I looked to see. I look at whether Radio D was reporting. Of course, this isn't the this isn't the spectrum from the 888. This is a spectrum from the Kiwi that's
Yeah, I'm
attached
wondering
to
how it would come out. How would it come out the antenna like that?
how would it come out the RF port and show up on the Kiwi?
Right.
Are they running from the same computer?
And no, the Kiwi is a standalone. And when the as I say, this is from KPH rather. If I went to in Santa Fe at KV6X, same, similar situation, antenna feeding a passive splitter going to a Kiwi and a 888, and I saw the similar kinds of bursts of these noise bursts, and at KV6X, I was able to instruct him to walk through some diagnostic steps. One of which was well, he didn't have a battery power for it, but I had him move the power for the 888, and let's see, and disconnect the Bogner and power the 888 from the wall wart, just a single USB wall wart, and these bursts still appeared. So there were no ground loops. I mean, there's the one ground loop that whatever is introduced by the AC power line, but nothing else was introduced. No ground loops through the Bogner cables and such.
I'd be tempted to put a 50 ohm resistor on the antenna lead of the 888 and, isolate where this might be egressing from the 888.
Well, I mean, there's, I'm not sure I understand that, what you're suggesting. It's I mean, or has it's a 50 ohm input already, right? So it's
well, yeah, but I mean, it could be coupling through power supplies. It could be coupling, what are the different ways it could couple into the receiver? Is it only through the antenna port that it's coupling?
at this point, well, I mean, the only way to completely float the 888, the only thing left to do on the 888 would be to power the 888 from a battery.
Right.
Then there was no other connection to the 888 other than the USB power from a wall wart and the RF antenna. That's what you're seeing. This is what you're seeing when in that configuration.
Okay, so you have a 888 powered by a wall wart, but it is sharing its antenna connection.
And yeah, that's it.
Okay, so you have only two coupling paths.
Yeah. Now, as I say, the only way to eliminate the next step would be, battery power the 888.
Well, he's suggesting that you put a dummy load on the antenna, I think, so that it can't get a signal from an antenna input.
Oh, well, I have no way, but at that point, I have no way of seeing what the 888 sees. I mean, if I disconnect the antenna lead going to the 888, of course, this disappears from the Kiwi's input.
Okay, so it's
so and if I put in a flux coupled isolation transformer, RF isolation transformer, on the input of the 888, the signal goes down significantly. Not entirely, but it's and surprisingly, even I still see it at 1 megahertz. You can't really, as you can see, that there's this is an AM blocking filter, and there's lots of LF signals coming in at KFS. So it's
okay. Well, there's a lot of front end stuff on the 888 before the A to D converter, so there could be something up in there doing.
Yeah,
that.
I just wonder if something, if something is being toggled by the, by the firmware or by a marginal signal for control of the attenuator or something like that, is introducing this. I'm not really asking anybody to solve this problem. I'm bringing up to this group because if you're designing this, our own version of this, we need to be able to be sure that this isn't happening in our design. That's my point, really. And without a spectrum display ability on the output of the 888, without this kind of a view, I probably would have missed this problem. The only reason I saw it is that I had the Kiwi attached and was looking at the Kiwi spectrum display. So I'm, I wish I tried to encourage Phil VK7JJ to see if he'd be interested in a little GUI project, but I couldn't.
Have you torqued down your SMA connectors?
What's that? If I
you
torqued down my
your
head,
SMA
they've been well. I did them, and I put them thumb tight. I don't want to because I'm going to remove them.
Yeah,
I don't double.
Always look at the simple things.
Yeah, that's it was. I did change connectors and cables, so it's maybe it's I will try it again. It seems hard to explain how the 888 itself could to generate this. So you're right, Phil. Maybe it's just
Yeah.
I have cheapo
I've been
cables.
bit enough times by those connectors, so
Anyway, I would on yours, if you have a similar situation, you might want to take a look for this problem.
Yeah, well, I will look. I just haven't noticed it, but mine are connected in parallel.
Yeah. Well, there you are. Okay. Well, that was my discourse on this. Is my report for the week.
Rob, I may sound erratic here, but if you try to connect your 888 to, say, Windows running SDR console or HD SDR, you should be able to see the full spectrum that way.
Oh, yes, of course. Well, but those are Windows computer probably. I think they only run on Windows.
Yeah, those are Windows. Yeah. So
I don't have
erratic here.
I don't have a really functional Windows computer.
Okay.
So I've been thinking I probably, I need to have one for things like that. But the one I have, strangely, and maybe somebody who knows Windows, mine was stuck in airplane mode. I can't get it out of airplane mode. So maybe the Wi-Fi section has died. Maybe that's why it's in airplane mode. But it doesn't tell me that. It tells me that I can't get it out of airplane mode. So it works if I have a Ethernet connector, but which works fine here in the lab, but I can't carry it out to sites and use Windows. Okay, there you are, guys. That's I'll turn it back to the network there.
I would like to share a screen and get some comments on it if it's okay with the group here.
I may say 7-3 because I got up really early today. So
I noticed you were yawning.
yeah, I'm starting to fade. But thank you. I'll leave it running and you can keep going, okay?
Let me ask you before you go. Those
Yeah.
slides you showed last time where you had the one graph that showed the full year or two of the impact of signals on the ionosphere. Is
Yeah.
that something you could share? I know you're working on it for a paper, but could you share that with me early? Or I'm going to have a group of people here for the microwave group and try to explain to them some of the things about what we're doing. And that really was a good illustration about the impact of some of these signals.
Yeah, I can send that to you.
All right, thanks.
You're welcome. I will do that.
So my shared screen here is my system that I've got set up with the 2 grape units. And I've got one of them is on an antenna that's oriented, it's a dipole, it's oriented north-south, and another one's on an antenna that's oriented east-west. And I built 3 of these grape units at the same time with more or less the same components. And I've tested all 3 of them. And these are the 2 extremes. The one on the top has got a lot more noise, so it's got all this yellow in it. And then the one at the bottom is a little bit lighter. The 10 megahertz WWV signals are coming through fairly strongly here at night, but during the day they fade down some, or they're not quite as visible. And so that's my concern, is that, you know, we're going to be, or I'm going to be trying to look at phase shift or changes in the signal through some noise. I think what I'm going to do is I'm going to replace this top one that's got more yellow in it with my other unit that approaches the bottom one. And the way the grape circuits were set up, they feed in through a filter and some capacitors right into a mixer port with the Bogner feeding the other side of the port. And I carefully looked at the output of the Bogner, and I put like 7 dB pads in front of both of them. I've got these systems both matched as closely as I can, trying to get coherence. Although I may lose it in GNU radio, because I had to run 2 different audio inputs. And so I'm not sure what's going to happen in the code there, how those 2 are going to get separated from each other. But anyway, I looked back at a picture that Joe put up here on the screen. I grabbed the screen copy of it a week or 2 back, and he had 2 different grape units there. Also, he had what he called grape 66 and grape 55. And I noticed like his grape 55 had a lot of yellow in it, so it had a lot more noise showing up. And then his grape 66 was very much more blue. Now he was looking at, this is like a raw signal I have coming in, and it gets further processed in this flow graph here, but he was looking at the one that's been processed more, so there's more averaging. Of course, when you do differential type things, and the noise kind of takes over in the differential measurement, which makes it hard to really compare the difference in east-west and north-south. So I don't know if other people are seeing these kinds of things or not, but that's what I'm running into here anyway. Any comments on any of this? Maybe people don't understand it. Anyway, that's my fight. That's my battle here. So back to you guys if you got something else to go over.